Hello, I'm John Frisbee of YouthTutors.com, and I'm going to go through an example of differentiating an inverse function. A filter funnel is in the shape of a cone of vertical angle 90 degrees with a small tube leaving at the vertex. Here's a little diagram of it. Notice in this question the height of the level equals the radius, h equals r. When the depth of the liquid in the funnel is 4 centimeters, so that would be h, the level is falling at 0.2 centimeters per second, and at what rate is the volume decreasing? Let's look at what we're given and what we need to find. Which says when the depth of liquid in the funnel is falling at 0.2, so the change in height is 0.2 centimeters per second. We need to find the rate of that the volume is decreasing, so we need to find dV dt. Now, using the chain rule, dy dx equals dy du du dx, I'm going to change the differential functions in that, and we're going to say if we want to find dV dt, we can say that, and we know dH dt. I think the budding mathematicians there will be able to see that if I put dV dt in here, that the
dV dH.
dV dH, beg your pardon. dV dH in here, then the dH's will cancel out and I'll be left with dV dt. dH dt is 0.2, so we've got to find an expression for dV dH. In order to do that, I'm going to look at this expression for the volume of a cone, and I'm going to put it here. If V equals 1/3 pi r squared h, if I differentiate that, knowing that r is h here, so it becomes h squared h, which is h cubed. So in this particular example, v equals 1/3 pi h cubed, so dv dh is going to be 3 times 1/3 is 1 equals pi, and reduce the power by 1, so it becomes pi h squared. So I can put, and let's have a look, pi h squared, when the depth of liquid in the funnel is 4 centimeters, so that will give us, if h is 4, we're going to get 4 squared is 16 pi. So we've taken dV dH, we've dropped it in here, and that becomes 0.2 times 16 pi, that's a fifth of 16, which is 3.2 pi. Now this is dV dt, so the units will be centimeters cubed per second. And that's part one. I'll just underline that, disappearing for a moment. And I'll just put that dV dt. Part two, if the rate in part one is steady, so that means we have found that dV dt, we know dV dt equals 3.2, I won't put in the units for the moment.
3.2 pi.
3.2 pi, sorry, thank you Harry. If dV dt equals 3.2 pi, how fast is the level falling when the depth is 2 centimeters? So dV dt we want, so 3.2 pi, substituting in here to dV dt, equals dV dH times dH dt. It's the h dt that we want, the rate that the level is falling. So what is dV dH? dV dH we found earlier was pi h squared. I'll put that in here. Pi h squared times dH dt. H is 2 centimeters, so we're going to get 4 pi times dH. I'm going to, I'll carry on for now. That's 3.2 pi, and a little bit of a rearrangement gives us dH dt equals 3.2 pi over 4 pi, and that equals 0.8 centimeters per second, and that, I will emphasize, is dH dt, which is the answer to part 2. Here we are. Okay, so we've used the chain rule, obviously quite a bit of algebra. We've had to use the inverse function for this, and we've come up with a nice little example of this type of question. I hope that helps. Look at it several times if you want. Okay.